Okay, so now let's try to solve our dynamic program. Um, so in this case, basically we still use backward induction to solve our dynamic program. Once we have this optimality equation, then basically the problem has been well defined and the relationship has been set up. So basically that's a valid dynamic program. In this case, if we want to do it, we still go from the last period. We will look at the last period to make an optimal decision given any state. And then we will move a little bit forward, backward to the period 2. Do it again. Period 3, do it again. Basically, that's the same thing. It's just that now when we want to do the calculations, we need to work on expectations. And that demand distribution certainly helps. Okay? And even though we may do all the things by our hands, obviously, writing a program will help. Okay? So let's see specifically a numerical example. Let's say we have 5 days and we have retail price 5, purchasing cost 2, and our random demand is binomial with 10 as the upper bound and 0.3 as the purchasing probability. So you may think about in the case that each day you will have 10 arrivals, 10 customers will show up, and for each of them there is a probability 30% that this person will buy it. Okay, so once you specify all the things here, basically you know how to solve it. So once we have a computer program that moves from period 1, period 2 up to period 5, we will be able to generate a table like this. This table lists Qt star as our optimal decision to do for each period. Okay, Qt star obviously depends on what? Depends on your t and your y. Okay, so let's take a look. For example, this number means if you have 1 day left and you have nothing on hand with you, your optimal decision is to order 3 units. Okay? If you already have 1 unit on hand, then you're going to order 2 units. Okay? Because your QT is your order up to level. So if you have no greater than 3 units, you will get to 3 units. Okay? And you can see that if you have 4 units, 5 units, whatever, once you have more than 3 units, you don't want to make an order. So what does that mean? That means your Q1 star is actually 3. Okay? It has nothing to do with Y because given any Y, you try to make your inventory become 3. If that's possible, you do it. Otherwise, you just don't order anything. Okay? Then what would be Q2? Q2 obviously is 5, right? If your inventory is no greater than 5, make it 5. Otherwise, don't do anything. Your Q3 is 7, Q4 is 8, Q5 is also 8. So you can see that basically we can find optimal solutions for each period. And we may also see that in each period, the order up to policy is actually optimal. Okay, so for every period, we can find that order up to quantity. And if your inventory is less than that, fill it up. Otherwise, don't do anything. And we may also see that the order up to quantity actually increases in T. Okay, when you have more periods, when you move from 1, 2, 3, 4, 5, your Qt star goes up. This is 3, this is 5, this is 7, these are 8, right? That means when you know that you have more periods to go, then you're going to prefer to have more, because in that case your overstocking risk would be low. You still have many periods to go. Why not have more inventory on hand? You still have many periods to sell them, right? Or on the other hand, you may also say that you want more inventory because you want to reduce your understocking cost. you still have many periods. Each period there will be some random demand. If you have just a little bit inventory, then you are going to sold out. That's not a good idea. If you have just 1 or 2 periods to go, you will consider to have, well, 3 units, 5 units. But if you still have a lot of periods, you're going to order more. One interesting thing that you also may observe is that, well, it seems that this is going to have a limit. If we have 5 days to go, we order up to 8. What if we have 6 days, 7 days, or 10 days, or 20 days? If we still have 100 days to go, will we order 9 units, 10 units? Will we have order up to levels that are 9, 8, 10, 11, whatever? Well, basically, you need to look at your inventory, your demand distribution. Your demand distribution is binomial, where your N is 10 and the probability is 0.3, right? And don't forget, you may still replenish every period. So basically, there is really no reason for you to replenish a lot to have your inventory level more than 10. There's no need to do that, right? Because you can still order once you feel that you don't have enough. So that's why this naturally have some kind of diminishing marginal benefit effect. You're going to order more if you have more periods to go. But if you really have a lot of periods to go, you don't order that much. Your order quantity and your number of periods is going to be some kind of concave function relationship. Okay, that makes sense. We are actually also able to characterize that Vt of y. In this case, it's obviously calculated by computer programs, so we're going to ignore the details. But you can see that once we have probabilities, we are able to find all the numbers here. For each number, for example, here, that means if you have only 1 day left, and if you have nothing on hand, you do your optimal decision. In expectation, you earn $6.19. For example, here, if you have 3 days left, and you have 6 units with you at the beginning, then you do your optimal thing, and you earn $35.9 in the next 3 days in total, in expectation. So that's the meaning of this table. We may again see some interesting findings here. In each period, we know it's better to have more initial inventory. That makes sense, okay? So if you look back to the previous slides, for any period, if your y goes up, you always earn more in expectation. Well, that makes sense. If your father leaves you a lot of inventory, a lot of money, you're going to have a better life, right? But the better thing is going to have a diminishing marginal benefit. Once you have only 2 units, give you 1 more, you feel very happy. But once you already have 20 units, give you more, well, that does not help a lot. Also, given the same amount of inventory, then it's better to have more periods, of course. If you have 3 units now, then if I give you 1 more day, well, you may certainly earn more money, because for that day, you can sell the products that you cannot sell. And also, you still have the chance to do the ordering, right? So it's going to make you better off anyway. Your profit will go up. Expected profit will go up as long as you get more periods.